All right, penultimate lesson, right? We'd have one more in this unit. Yes. So this one and then one more, and then we're through. So this lesson is kind of like the last lesson. Actually, it's stuff from the last lesson, kind of, and review of stuff that we've been doing practically all year, and basically just a little bit harder problems. Basically, um, it's so I don't know that I don't know whether you're going to find this lesson to be particularly hard or not. Let's kind of dive in and see. So the first, we've been using this property just nearly all year. Actually, we've already talked about reducing radicals and all of that kind of stuff. We talked about reducing them with variables in them in the last lesson. So we've used this a lot, but kind of formally in Algebra 2 notes. Here we go. Yeah, there you go. Let's do some examples with this, that combine some of the things that we've done. So on this one, we are trying to reduce the square root of 32, right? Excuse me. And the square root of x to the 8th, right? And so we can kind of treat this as two separate things, right? So this, remember, when we're doing this, what we want to do is we want to find perfect squares that go into 32. So what are our perfect squares? Well, there's 4, because 2 times 2 is 4. There's 9, because 3 times 3 is 9. 16, 25, 36, etc., right? We go on forever with that. So do any of those go into 32? Well, 16 times 2 is 32. You can verify that on your calculator if you want to, of course. But 16 times 2 is 32. So we can split this into the square root of 2, or let's do 16 times 2. And then this, we can do just like what we've been doing before. And can we split this into something where we multiply times 8, and it's something that we can do squared. I was thinking about 3 things at once, and so I was trying to not be confusing, and I probably was confusing, or I maybe just sounded like I was having a stroke. I promise I wasn't having a stroke. My brain was just running in too many paths at once. So let's what can we do with this x to the 8th? In the last lesson, we were trying to get this as x to the something else, right? So where we multiply 2 things. So 8, we can get it into 4 and 2, right? So we can do 4 times 2 is 8, so that will totally work. That's we're going to learn in this lesson that sometimes you can't do it this way, and we've got to split it up differently, right? And so we can do this. In fact, we're going to do this one differently as well, just to kind of show, to show that you can do things in a different way and all of those things. And so a different way of looking at it is we can split it into where we're doing x times something to x to the something else. So we can split it into where we're adding the exponents, right? That we could also split into. And I said we're going to do that on this problem where I changed my mind, and we're not, because we'd have to split this into x to the 2 times x to the 2 times x to the 2, and it's just going to get a little bit ugly. So let's revert to what we know, right? So this is x to the 4th squared, right? Right. So now we can take care of all of these bits. The square root, we can split this into x, the square root of 16 x to the 4th squared, right? These ones are all the ones that we know the square root of, right? Because we can cancel the square and square root on this one, and this one, we've got square root of 16 is 4. And then we're just going to make sure we leave and don't take off the square root of 2. So in this one, we get 4, because 4 is the square root of 16, and x to the 4th times the square root of 2. There we go. That's as simple as that one gets. Easy peasy. Let's take a look at this one. Now, this time we've got the fourth root instead of a square root, right? So it's a little bit more scary, but let's see if we can figure out, is there something to the power 4 that equals 16? Well, 2 to the 4th equals 16, so that was easy, right? So this one was easy peasy. So we can split this into the fourth root of 16. Fourth root of 16. Now, we are going to want to get this as something to the fourth, something to the fourth, right? A to the something to 24. So we want to know, can we multiply something to get 24, right? No. I'm sorry. I don't know where my brain is this afternoon. It's like in La La Land and whatever else. Can we do 4 times something to get 24? That's what I'm trying to say. Difficultly for some reason. Right? Yes, we can, because 6 times 4 is 24. So we can get that one as the fourth root of a to the 6th to the 4th, right? And then we can get this one. Now, this is where we can't just do that, right? Because it's a 13. So we can't get it to something that's going to be a 4. We can't do nothing times 4 equals 13, but we can do something else. So we can do this. So we can switch it to multiplication instead of a power to a power, like bases multiplied. So we can split this into b to the 12th times b. Remember, if there's nothing there, it's a 1, right? 1 plus 12 is 13, right? So we split it up. And we split that up because 4 times 3 is 12, right? So we can get that one. We can take care of this one. Now, this one's probably just going to hang out. We're not going to be able to do much with him. Fourth root of 16 is 2. Fourth and fourth root cancel here, so we get a to the 6th. This one we're going to split up into the fourth root of b to the 3rd to the 4th, just like we've been doing, times b, right? I mean, but a times. You don't have to, but I'm even going to put that there just for more fuller clarity, right? And so we can split these up using that product property, just like what we've done with all of these, with any of these other things, right? Just like they were numbers. So the fourth root of, and I'm going to go ahead and put this intermediate step in here, of b cubed to the 4th times the, extend that just so it's clearer, times the fourth root of b. Now that one we can't do anything with, so he's going to stick around to the end. On this one, fourth root and fourth cancel, so we end up with 2a to the 6th b cubed times the fourth root. Make sure when you're doing that, it doesn't, your handwriting works well, and so we don't think that it's 34. You might even put a times if you feel like it's going to look confusing or whatever else. But there we go. Let's do another. We've got several examples in this particular thing. This is not obviously an example. This is quotient property. So the quotient property, and we've used this. I think we've used this year. Anyway, so if we have a nth root of a fraction, then it applies to the top and the bottom, right? I think we've definitely done that. You've probably done it in Algebra 1, if nothing else. So let's simplify these. So we've got the square root of x to the 6th over y to the 7th. So let's start out by turning this into the square root of x to the 6th on top and the square root of y to the 7th on bottom. So on the top one, we can turn it into something that's got a 2 in it, because 3 times 2 is 6, right? And we want the 2, right, because it's a square root. If there's nothing there, the one weird exception, it's not a 1, it's a 2 in a radical, right? And so this can turn into the square root of x cubed squared, right? Because 3 times 2 is 6. I'm just converting that, right? Over, should have made that radical bigger. Sorry. This one we can't because 2 times nothing is 7. But if we turn this into y to the 6th times y, because 6 plus 1 is 7, right? Like base multiplied, you add them. Now we can get this taken care of, right? So we're going to turn this top one is easy peasy. Make it plenty big this time when I don't really need, oh, just kidding. I don't even need that at all. That was totally a waste of time. So the squared and square root cancel on the top, leaving us with x cubed on the top. And then on the bottom, we end up having the y cubed squared times y, the square root of y, right? I went ahead and did the split up in one step there, that along with changing it, and then the square and square root cancel right here. So what we're left with on this one, x cubed over y cubed times the square root of y. Now, we're not done with this one, unfortunately, because we don't like radicals in the denominator. So we need to get rid of this radical in the denominator. So for something like this, we're going to remind ourselves how to do a conjugate at the end, at our last example of this. But when we're doing this with this one, all we have to do is we're about to multiply the top and bottom times that root, right? And that's going to get rid of it on the bottom. So we're going to multiply it times square root of y over the square root of y, which is just this one. Because on the bottom, we have y, the square root of y times the square root of y, which the square root of y times the square root of y is y, the square root of y squared, right? That's this times this. This times itself is this times itself squared. Or this. I don't know why my words are coming out all jumbled. I apologize. So that's going to cancel. So it's just going to be a y down here on the bottom, right? So on the top, we have x cubed times y squared, the square root of y over y cubed, that's this y cubed, times y, and it's just y because of this, because y, the square root of y times the square root of y is the square root of y squared, gives us a y. Now, we can do one more thing to simplify because we have like bases on the bottom, so we can add those, they're multiplied, so we can add the exponents, right? So x cubed times the square root of y over y to the 4th. Great. Let's take a look at this one. Okay, so I've made an executive decision that we're going to, for this lesson, we are going to omit problems where we have to rationalize the denominator and it's not a square root. It's something larger than 3. Because, we're going to learn how to deal with it in the next lesson. Because doing this, in my humble opinion, doing this in this way is way more confusing than doing it with rational exponents, which we're going to learn in the next lesson. And so if I have assigned you ones where you have to rationalize the denominator and it's bigger than a square root, we're going to omit those, and I'm going to omit this part of the lesson because we could do it, but it's super confusing to do it this way. I think it's a lot easier to think about with rational exponents, which we'll do in the next lesson. So we're going to omit ones like that in this lesson. We'll pick them back up in the next one. All right, so this is a fun problem, right? So we got a lot of mess. See if we can deal with this lot of mess. So what can we do first? Well, we can multiply 5 times 3 because this is multiplied times, let me show what I'm saying. This is multiplied times this is multiplied times this times multiplied times this, right? And multiplication, the commutative property applies, which says we can rearrange it. If it's all multiplication, which it is, because these are kind of like hidden with the square root. And so we can multiply 5 times 3 and get 15, right? Now, what else can we do? Well, here's what else we can do. So on the product property, way back over here, you notice that this is an equals, right? So it's symmetric, which means we can take it from, we can go this way, but we can also go this way, right? So we can undo what we have done, right? So this is the cube root of all this mess times the cube root of all this mess. Why would we want to do that? Well, because we got a's over here and b's over here, and if we just turn this into one big radical, then we can maybe combine them and get at them and make it something cleaner. So what we're going to do is we're going to turn these two radicals into one big one. So the cube root of -12, and I'm going to go ahead and put this times 18 here. Put the numbers together. I'm not gonna multiply those yet, and we'll talk about why here in a second. And then times a times b, no, times, I'm going to put the a's together, so times a squared times b to the 4th times b squared, right? So now, what are we going to deal with next? Well, what are we going to, well, we want to deal with these. So we've got a cube root here, right? So we need to get these, if we can turn these into something cubed, then we're going to be sitting pretty, right? That's going to be because then we can cancel the cube and cube root, and then we're left with whatever is down here, and that sounds great. Now, nothing cubed equals 12, right? Nothing does, because 2 cubed is 8, and 3 cubed is 27. So that doesn't work. So we're going to kind of take a play a little bit out of our playbook where we can split this into split the a's like bases up. We're going to use this, and we're going to use another operation. So we could turn this into something times 12, something times 18. 18's a nice easy one, maybe, right? Because of 9, but no, that doesn't work because it's not 9. 2 cubed equals 8, not 9. So that doesn't work. So what do we do? Well, can we turn them into the same things, maybe? Could we get them into the same bases so we could maybe combine stuff? What am I talking about? Well, can we get 12 and 18 down into the same bit? So what are the factors of 12? Well, it's 6, which the factors of 6 are 3 and 2, and then 6 times 2. So we've got this into 3s and 2s. Can we turn 18 into 3s and 2s? Maybe. Let's see. So 18, we can do 9 and 2. That 2, we got a 2. Oh, and 3s. So we can turn 18 into 3s and 2s, and we can turn 12 into 3s and 2s. So that might be useful, maybe. So let's see if we can do that. 15 times the cube root of, so 12, we're going to turn it into 2 squared times 3, right? And 18, we're going to turn into 3 squared times 2. All I did was pull out from these factor trees the factors. That's all we did there. And so we can turn this into -2 squared, -2 squared times 3, times 3 squared times 2. And we can combine these like bases. We may be able to do something with that. So we've got a cubed. Oh, that's nice, right? Cubed, cube root. That's already going to cancel. What about the b's? So like bases multiplied. Remember, we add, just like we did with the a's. So b to the 6th. Ooh, that looks like it's going to work because 3 times 2 equals 6. That's good. So we can turn it into b squared cubed. Okay, we're looking pretty. So these we can do easy. Now, we've got some like bases over here. We've got the 2's that are alike and the 3's that are alike. We have like bases multiply. We can add the exponents. So 2 plus 1, where is it? Yeah, 2 plus 1 is 3. So 15 times the cube root of -2 cubed. Again, that's 2 plus the 1 here. 2 cubed. Cube and cube root. Cancel. Looking up. 3 to the first. So times 3 cubed. Ooh, that's looking great. That's looking really great. And then a cubed, we already said we knew how to deal with that. And we can go ahead and turn b to the 6th into b squared cubed. Look at that. That's awfully nice. Okay, so all of these cubes cancel with the cube root, right? And so this will turn into 15 times 2 times 3. That's 2 and 3 times a times b squared. Now we just do 15 times 2 times 3, which, oh, what did I do? I left off a negative, right? Gotta have that there because it's an odd root. The negative stays. He don't go away. So 15 times negative 2 times 3 is negative 90. So negative 90 a b squared. Isn't math fun? We can take an ugly mess and turn it into something a lot cleaner and a lot simpler. All right, let's do another one. We have 3 more, and most of them are not really as long as that. So we're going to simplify this. So we got a bunch of numbers. So you punch it in the calculator, and you're going to get approximately equal to something stupid, right? So in math, I've talked about this in class, but I don't know if I've talked about this on video before. But in math, in a math class or in a mathematician, we want to keep our numbers as exact as possible. That way, the physicists and engineers and all of those people, or chemists or whoever, they can use our formulas that we develop in exactness, and they can use them with whatever precision that they're measuring or whatever else. And so we're delivering something exact. So we don't want approximately equal to. We want this. We want this exact thing. So we've got kind of a mess here. Let's see if we can simplify it. So we're reducing radicals. So we need to find perfect squares that go into 48 and 32. Now 32 is easy. We've seen that already today. Let's go ahead and jump straight to that. So 2 times the square root of 16 times the square root of 2, right? Because 16 times 2 is 32, right? We've already done that one already in this lesson. So this one's a little bit scarier. So what are our perfect squares? There's 4, there's 9, there's 25, there's 16, et cetera, et cetera, et cetera. So you may not be able to tell right away which one goes into 98. And so what you do is grab your handy dandy calculator and start sticking stuff in the calculator, right? So 98 divided by perfect square. So let's say 16. Does it work? It doesn't work. It gives us a fraction, right? So 98, it's not going to be 25, obviously, right? It's not going to be 25. So what's next? 36. So hit 36. Divided by 36. Enter. No, that doesn't work. So I've only counted in this particular lesson up to 36. So what's the next one? It would be 7 times 7, which is 49. I'm sounding hopeful because I know the punchline. Divided by 49. Enter. It works. 49 times 2 equals 98. So we can turn this into the square root of 49 times the square root of 2. Ooh, look, those roots match. Foreshadowing for the future. Square root of 49 is 7. And then we still have the square root of 2 minus 2. Square root of 16 is 4 times the square root of 2. So we can do a little simplification here, right? So 7 times the square root of 2 minus 8, because negative 2 times 4 is 8. And then we've got the square root of 2. Now, we can do one more thing. It's easy. Don't stress. We're good. I know that last problem freaked you out. I know that was like a lot. But, we'll sit with it, practice it, do some more things, ask questions, all of those things. We got this. Now, if we had 7x minus 8x, we would combine like terms, right, and get negative x. Same thing here. We can basically treat the square root of 2 like it's a variable, kind of, right? And we're going to combine like terms because these are like terms and turn this into negative x, or in this case, negative square root of 2. which is great. Like we're using that, handling that, so much simpler to take this and turn it into that. Wonderful, great, grand, glorious. So let's do this one. I should have brought this down. In fact, I'm going to cheat and bring this down a little bit because I want to draw arrows. Oh, I know, I'm not in the right layer. There we go. Bring it down. Deselect, brush. So simplify this. Well, we've got a binomial times another binomial. What do we do with that? Well, we FOIL it out, right? So we do a big old distributive property. This times that, and this times that, this times that, and this times that. Everything times everything. If it's binomial, it's FOIL, whatever else. With this, I don't know if I would recommend the shortcut because it might get a little confusing in your head for some of the bits. So we got to do 4 times the square root of 3 times 3 times the square root of 2. So I'm going to show you this explicitly. I'm going to skip a little bit on some of the next ones. Actually, this is the only one that's like weird. So I'm going to show it over here and write it over there, right? So the 4 times 3 is 12, right? And then we've got square root of 3 times the square root of 2. So just like we did on that scary problem, if you have a square root times a square root, you can put them back into one square root, or in that case, it was a cube root. All right, so I'm going to do that here. So I'm going to turn this into the square root of 3 times 2, which is 6, right? Makes sense? I hope so. If not, let me know in the comments or in class or something, right? So we're going to turn this into 12 times the square root of 6, and then 4 times the square root of 3 times negative 6. That's just going to be negative 24 times the square root of 3, right? Kind of treat it like a variable, right? So negative 6 times 4 is negative 24, and then the square root of 3 just hangs out for the ride, right? So now we're going to do 5. No, this is another one like that. So 5 times the square root of 2 times 3 times the square root of 2. So we're going to do just like we did up here. So 5 times 3 is 15, so plus 15. And then the square root of 2 times the square root of 2 is the square root of 4. Ooh, that's nice because that's something we know, right? 5 times the square root of 2 times negative 6 would be negative 30. Because 5 times negative 6 is 30. And then the square root of 2 just comes along for the ride. All right. So what else can we do to simplify? So do we have anything in common? Do we have... What can we simplify? Well, only thing I'm seeing, because these radicals are as simple as they can get, right? So the only thing I'm seeing is that we can take care of the square root of 4 and turn it into 2, right? The square root of 4 is 2. So we've got 12 times the square root of 6 minus 24 times, the square root of 3 plus 15 times 2. Not the square root of 2. That is, as I'm writing this down, that is still a common mistake that gets made, is when you take the square, when we get all this stuff with radicals, it gets so much and your brain gets twisted up. Just, even me, I don't know what's going on. Obviously, I'm starving, so maybe I'm getting a cold. Who the heck knows? But it's easy sometimes when you take the square root to be like, square root of 4 is the square root of 2. No, it's not. The radical goes away, right? Because square root of 4 is 2, not the square root of 2. So don't make that mistake either on accident and definitely not on purpose. Right? So we can do one more thing. Easy peasy. 15 times 2 is 30. So 12 times the square root of 6 minus 24 times the square root of 3 plus 30 minus 30 times the square root of 2. And that's as simple as it gets because there aren't any like terms. Great. One more problem. This one is actually not so bad, so let's make it so. Woo. All right. So we're going to use a conjugate to rationalize the denominator and simplify. So we've done the conjugate before in this class, and which was maybe review from Algebra 1, maybe not, depending, your mileage may vary and all of that. But remember that the conjugate is just the denominator with that middle sign switched. And so our goal, what we're trying to do remember, is we don't want square roots in the denominator. Now, this is a square root, so this wouldn't be one of the ones that I told you we're going to omit, right? Because it's a square root, not a cube root or a fourth root, or etc., right? So to rationalize this, we multiply it times the conjugate. So what is the conjugate of square root of 5 minus 1? What's square root of 5 plus 1? Because like I just said, it is the same as the denominator with the middle sign flipped over the square root of 5 plus 1, right? So on the top, we're just going to distribute, easy peasy. And on the bottom, we're just going to distribute. Now, something's going to drop out of this one. And if you remember what's going to drop out, which you may at this point, we've seen a lot of stuff like it. You can skip to the good part, so to speak. But if not, just follow along because I'm going to show all the intermediate steps, right? So on the top, we got 2 times the square root of 5. So 2 times the square root of 5. And then 2 times 1 is 2. Great. There's the top. Easy peasy. Happy. All right. The bottom, we've got the square root of 5 times the square root of 5, which would be the square root of 5 squared, which means the radical cancels, right? Square root of 5 times square root of 5 is just 5. And I'll explicitly write that over here because it turns into 5. Square root of 5 squared, square root cancel, right? That's what we're doing. Now we've got square root of 5 times 1. So we've got plus the square root of 5. You're like, oh no, there's a radical. Don't worry, it's going to go away here in a second. Minus the square root of 5, because negative 1 times the square root of 5 is negative square roots of 5. And then negative 1 times 1 is negative 1. Square root of 5 minus square root of 5 cancels. And what I was alluding to earlier is that outside and inside, the outside and inside of the FOIL, they always are going to cancel, always. So you can just do the first and the last. Save yourself some time if you remember that. Because, and that's why the conjugate works, because it forces that to happen. It kind of turns it into multiplying the difference of two squares, essentially, kind of. And so the top, nothing can happen to it, because it's as simple as it goes. 2 times the square root of 5 plus 2 over, and then 5 minus 1 is 6. There's one more thing we can do. We're not quite finished. Did you see it? Did you see it yet? You probably did, because we've been doing this with polynomials a lot. Every single one of these terms is divisible by 2, so we can factor 2 out, and we can reduce the whole thing by 2. So 2 divided by 2 is 1. So this turns into the square root of 5. 2 divided by 2 is 1. So this turns into 1. 6 divided by 2 is 3. There we go. Big smiley face. We are done because I messed up in the middle and had to do some things. I'm going to go edit this video and get it uploaded. If you're in my class, do your homework. See you later. If you're not in my class, hopefully this was helpful to you. Let us know how we can help you with math, science, or homeschooling in general. Don't forget to like, comment, and subscribe, and other nonsense. See you later. Have a great day. Bye.